In this video, I'll show you how to solve logarithmic equations with different bases. So this question is asking us to determine all real numbers where x is greater than 0, for which we have this equation. And notice that here we have log of base 4, log of base x, and log of base x. So how do we solve an equation with logarithms of different bases? As you can see, we have two terms with the base x. We have this term and that term. This term has a base of 4. So let's go ahead and change the log base 4 of x into log base x. What we do is we use this important formula where notice that we have log base 4 of x. If we match this to the formula here, 4 represents b and x represents m. So we'll write down log base 4 of x is equal to log, and a will be the base that we want. The base that we want is x. So log of base x, m was x, over log of base x again, and b was 4. I'm going to go ahead and erase those annotations. So all I'm doing here is converting that first term so that it has a base of x. But we still have a long way to go. Notice here we have log of base x of x. Because the base and the argument are the same, that is, both of these are x, then that simplifies to 1. So we have 1 over log of base x of 4 represents log of base 4 of x. So what I will do is I'll replace this term with that expression. Let me go ahead and rewrite the equation. Now to simplify the equation a little further, I'll take this term and move it to the right side and apply some log rules. Here's what I mean. So I'll leave this as 1 over log base x4 is equal to 7 over 6 minus log base x of 8 plus log base x of 16. I'll change the position of these two terms, that way this one is first and that one is second. A little bit of editing magic there. And now we'll apply the log rule, where if we have two logs of the same base being subtracted, we can divide the arguments. So here we have 16 divided by 8. So 7 over 6 plus log base x. 16 divided by 8 is 2. And what I'll do next is get rid of this fraction by multiplying every term by the denominator log base x of 4. So let's go ahead and multiply each of these terms by that factor. What this will do is it will eliminate the fraction here, giving us 1. Then we'll have 7 over 6 log base x of 4 plus log base x of 2 times log base x of 4. This 4 can be written as a power, where you have 2 to the power of 2. So let me go ahead and show you why that's important. I'll actually do the same thing here. I'll write this as 2 to the power of 2. So we end up with 2 to the power of 2 over here. Applying another logarithmic rule, where I can write this as a product of the exponent times the log, I end up with 7 over 6 times 2 times log base x of 2. And the 7 over 6 and the 2 multiply to give us 7 over 3. And now you'll notice some similarities in the components here. So if I apply the same rule here, then I can write this entire thing multiplied to a factor of 2, and that gets rid of that exponent of 2. We have 2 log base x of 2's being multiplied, of which we can write it down as a power. So you can write down plus 2 log base x of 2 raised to the power of 2. this and this are identical, and so we can do a quick substitution here where I substitute this with the letter u, for instance. And watch what happens when we do that. We have 7 over 3 u plus 2 times u to the power of 2. And that is a quadratic. If I move this over, I end up with 0 is equal to 2u squared plus 7 over 3u minus 1. Now you have to use the quadratic formula to find out what u is. Now I'm assuming you know how to use the quadratic formula. So I'll just use the function on my calculator to find the roots of a quadratic. I'll put in 2, 7 over 3, and negative 1. And this will quickly give us the values for u. We get u is equal to a third, and u is equal to negative 3 over 2. So that's our value for u. And remember, our u substitution, I didn't write it down explicitly before, but our u substitution was log base x of 2. And now that we know what u is, it's 1/3 and negative 2 over 3, we can actually solve for x. We can raise both sides of the equations as exponents to the base x. And what that will do is it will eliminate the x and the log base x, giving us x to the power of 1/3 equals 2. Cubing both sides, we end up with an x value of 8. We'll do the same thing again. Negative 3 over 2 is equal to log base x of 2. This will become the exponent, and that will become the exponent. The base and that part will cancel out. And now we have to solve for x. One more time. This can be done by multiplying both sides by 2 over 3, and that has to be negative. So x is equal to whatever that is equal to. Let's use our calculator once more. 2 to the power of negative 2 over 3. And that's equal to roughly 0.63. And so there you have it. That is how to solve log equations with different bases. Any questions, let us know. Thanks for watching.